Differential scanning calorimetry is a thermal analysis technique that looks at the material's heat capacity with change in temperature. This allows the detection of changes in the material with the change in temperature, such as melting point of crystalline phases, glass transitions in case of amorphous material, and other phase transitions. DSC analysis provides test data for a variety of materials, including polymers, plastics, composites, laminates, adhesives, food, coatings, pharmaceuticals, organic materials, rubber, petroleum, chemicals, explosives, biological samples, and more. When developing a substance as a candidate pharmaceutical product, tests are performed to identify and characterize possible polymorphic forms. Depending on how the material was produced or treated, it may exist as several crystalline structures, which may have different solubilities, reactivities, and thermal behavior. The information characterizing polymorphic forms is required for legal protection, processing, shelf life, and solubility considerations. Differential scanning calorimetry, or DSC, can be used not only to determine the melting point, which is unique to a given crystalline state, but also to better characterize a polymorphic system. Generally, DSC samples are prepped in an aluminum pan with or without the lid. A sample size of 5 to 10 mg is recommended, depending on the sample density and texture. Using a hermetically sealed or crimped pan can help avoid solvent loss and avoid exposing the sample to ambient humidity and temperature conditions. A pinhole is generally recommended for a sealed pan to avoid pressure buildup inside during the experiment due to the gas produced during the decomposition or solvent loss. An exception to this would be using a pinhole for amorphous material, where it is essential to note the glass translucent temperature in presence of water or solvent to evaluate its effect on the suppression of the glass transition. The technique chosen for the sample prep will depend on the sample type and the desired outcome. In this section, we will be covering topics including the heat of transition, decomposition, stability, monotropic versus anisotropic relationships and transitions, and advanced DSC characterization.